Have you ever wondered what the world was like before you could just flip a switch and light up a room? For your phone, your computer, your everything? It was a world lit by fire and powered by muscle. But then, one man's curiosity sparked a revolution that would electrify the entire planet. This is the story of how Alessandro Volta, with a simple yet ingenious invention, plugged us into the modern age. Our story begins not with a bang, but with a twitch. In the late 1700s, an Italian scientist named Luigi Galvani was dissecting a frog. He noticed that when his metal scalpel touched the frog's leg nerve, while another metal tool touched a different part, the leg kicked, just as if it were alive. Galvani believed he had discovered animal electricity, a special life force flowing through living creatures. It was a fascinating theory, and it took the scientific community by storm. Everyone was talking about it. But across Italy, another scientist, Alessandro Volta, was skeptical. He was already a big name in the world of science, known for his work with gases like methane. Volta respected Galvani, but something about the animal electricity theory just didn't sit right with him. He thought, maybe it's not the frog. Maybe it's the metals. So, Volta started experimenting. He ditched the frog legs and instead, he placed his own tongue between two different types of metal plates, say, one silver and one zinc. He felt a bizarre, sharp, and slightly sour taste. It was an electric sensation. This simple, and probably not very tasty, experiment convinced him he was on the right track. The electricity wasn't coming from an animal. It was being generated by the two different metals. The frog leg, and later his own tongue, were just acting as conductors and detectors for this new kind of electricity. This set the stage for a great scientific debate. On one side, Team Galvani, believing in a mystical life force. On the other, Team Volta, arguing for a new physical phenomenon, electricity generated by metals. For years, they published papers, conducted public demonstrations, and argued their points. It was the scientific equivalent of a heavyweight boxing match, and the whole of Europe was watching. Volta knew he needed a knockout punch. He needed to create a source of electricity that was powerful, continuous, and had absolutely nothing to do with animals. He spent years trying different combinations of metals and liquids. He reasoned that the key was the contact between two dissimilar metals. But to amplify the effect, he needed to stack them. And so, in the year 1800, Volta built his masterpiece. It was beautiful in its simplicity. He took a series of silver and zinc discs and stacked them one on top of the other, separating each pair with a piece of cardboard or cloth soaked in salt water or a weak acid. He called it the Voltaic Pile. It looked like a column of coins, a strange metallic tower. It was, in essence, the world's first battery. When Volta connected wires to the top and bottom of his pile, he got a steady, continuous flow of electric current. It wasn't a spark that died in an instant like static electricity, nor was it a twitch in a dead frog's leg. This was a reliable, controllable river of electrical energy. He had done it. He had created an artificial electric organ that mimicked the power of an electric eel, but without any living tissue. The news spread like wildfire. Volta sent a letter describing his invention to the Royal Society in London, the most prestigious scientific body of the time. Scientists across Europe scrambled to build their own voltaic piles. The effect was immediate and profound. For the first time in history, humanity had a portable, continuous source of electricity. Imagine being one of those scientists. Suddenly you have this incredible new tool. What do you do with it? Well, the first thing many of them did was play with it. They used the current to decompose water into its basic elements, hydrogen and oxygen. This was a monumental discovery, laying the groundwork for the entire field of electrochemistry. It proved that electricity could be a force for chemical change. They discovered new elements. Sir Humphrey Davy in England used a massive voltaic pile to isolate sodium and potassium for the first time, the substances that were previously locked away in compounds. The battery became the key that unlocked a whole new layer of the material world. But the impact went far beyond chemistry labs. The voltaic pile ignited the imaginations of inventors and thinkers everywhere. The concept of an electric current was now real and tangible. It sparked the fundamental questions that would lead to all of modern electrical engineering. How does this current flow? How can we measure it? how can we use it? Volta's invention directly paved the way for the work of Michael Faraday, who, a few decades later, would discover electromagnetic induction, the principle that allows us to generate electricity on a massive scale in power plants. Without Volta's battery to study current, Faraday might never have made his breakthrough. And without Faraday, there are no electric generators, no power grids, and no modern industrial society. It also led to the development of the telegraph. Samuel Morse's invention used pulses of electric current, sent down a wire from a battery, to transmit information over vast distances almost instantaneously. The first time, a message could travel faster than a horse. The world started to shrink, all thanks to that simple pile of metal discs. And think about the very words we use today. The unit of electric potential, the volt, is named in his honor. When you check a 9-volt battery, you are paying tribute to Alessandro Volta. His legacy is embedded in the very language of electricity. But what about the man himself? Volta became a superstar. Napoleon Bonaparte, a great admirer of science, was fascinated by the Voltaic Pile. He invited Volta to Paris, showered him with honors, made him a count, and gave him a handsome pension. Volta had not only won the scientific debate with Galvani, he had achieved international fame and fortune. It's incredible to think that this entire technological cascade, this electrified world we now take for granted, all started with a simple observation and a persistent question. Volta wasn't trying to invent the modern world. He was just a curious scientist trying to figure out why a frog's leg twitched. He followed the evidence, challenged the accepted wisdom, and through meticulous experimentation, he stumbled upon something that would change the course of human history forever. His Voltaic Pile was more than just a clever gadget, it was a paradigm shift. It moved electricity from the realm of parlor tricks and natural curiosities into the realm of a controllable, useful force. It was the starting gun for the electrical age. Every time you turn on a light, charge your phone, or start your car, you are experiencing the direct legacy of Alessandro Volta's pile of metal and salty paper, built over 2 centuries ago. He didn't just discover a new principle of physics. He handed us the key to the future. So the next time you use a battery, take a moment to think about that stack of silver and zinc coins. Think about the curious mind that refused to accept the easy answer and instead chose to build something new. That simple pile didn't just create a current, it created the modern world. Thanks so much for watching. If you enjoyed this journey back in time, don't forget to hit that like button. Subscribe for more stories from the history of science. And share this video with anyone who loves a good story about how the world works. See you in the next one.